So as Leo said, I'm a senior SRE at Deezer, but just before that, I was working in another company, which was called Lectra. And I'm going to talk about all the all the way we broke RabbitMQ and our apps along the way, because we learned the hard way and we made a few mistakes along the way. So a little bit of context. 3 years ago, I joined a company called Lectra, which basically builds these big machines which are cutting fabric and leather for the textile industry. And aside from this machine, Lectra is also building software for the textile industry. And historically, they were building software that came in CDs and that you installed in your own infrastructure with a big manual. And 3 years ago, when I joined, they decided to shift their business model from these on-prem monolith softwares to cloud SaaS, so software as a service, SOA architecture. And so they needed to switch to microservices, and they also needed to have a way to smoothly send messages and make sure all the messages were accounted for between those microservices and also between on-premise equipment, like the big machines in the factories I mentioned earlier. And I'm going to ask you, which software, of course, have we been using to do that? Of course, it's RabbitMQ. Why RabbitMQ? The first reason was that RabbitMQ came with not only AMQP support as a protocol, but also MQTT, which was really useful for us in communicating with the on-prem equipments. And as MQTT is really good for IoT protocols. We also liked the fact that we had an extra layer of abstraction in AMQP with the exchanges. As this was machines that were running 24/7 in production, and also the software, we needed something that was reliable. And RabbitMQ features clustering, high availability, and replication features. And and something that really helped us along the way was the fact that we had a management UI and REST API, and that we could configure our microservices topology on the fly. So starting again from scratch with no experience of microservices, no experience of message brokers, what could go wrong? And a lot has gone wrong. So let's break RabbitMQ. The first issues we encountered were really basic issues, mostly installation and design issues. In fact, the first thing you have to check when you are installing RabbitMQ and also a lot of other software is the OS parameters that you are going to configure. And the first error we did is something that is one of the first things that come in another talk from Michael Clichin's, which is called RabbitMQ Operations, which is from 2000 and still true in many cases, which tells you that you have to bump your file descriptors, because by design, most modern Linux OSs come with very low file descriptor limits for users. So it's 1024. And when you are running RabbitMQ in production with a lot of systems communicating at once, you need way more file descriptors. So we bumped it a lot, like 3000 or something like that. And we came in a really strange bug with the Erlang virtual machine, that when you had too many file descriptors, the whole cluster came down. But you can bump it now. It's fixed, and I assure you that you should bump your file descriptors. If you are interested in also fine-tuning really well your RabbitMQ, you can also check the Michael Clichin's or RabbitMQ operation, because there are lots of very fine-tuning network parameters that can be useful if you are stressing a lot your RabbitMQ cluster. The second issue we encountered was that when we talk about cluster in RabbitMQ, many people who don't know well RabbitMQ tend to think that clusters are like databases clusters or other kind of clusters. And when you are talking about clusters in RabbitMQ, it's not really what you think it is. As some of you may know, clusters in RabbitMQ nodes share all logical objects, but the important thing to say is that they don't share queues. Only one node at a time owns a queue. And what's really helpful with clustering in RabbitMQ is that all nodes know which queue is owned by which node, which allow you to just put a load balancer in front of your RabbitMQ nodes and give the consumer and producer's application the IP address of the load balancer, and then the load balancer transmits the messages to the brokers, and you don't have to worry which one is going to get the message, because RabbitMQ is going to magically give the message to the right node. That's fine, but when you come in production and you have your two RabbitMQ nodes with queues durable or not, and that you lose a node, what happens is that many people don't understand why they don't have access anymore to their queues and their messages. And that's because queues aren't magically replicated. Are still single points of failure. That's because, just like I said before, queues are owned by only one node. And if this node is down, you lose all the queues. You lose all the queues in two different ways. Non-durable queues are destroyed with all the messages within, and durable queues are blocked. And you have to fix the cluster in order to be able to redeclare them if you want to. And that's one of the biggest misunderstanding I have encountered many times with RabbitMQ clustering, not only at Lectra and also in other companies. People tend to think that cluster magically replicate their queues, while it's not true. So in our example, QA being durable cannot be redeclared in the other node, and QB is destroyed. So what you really want when you think clusters is basically two different strategies. Either you don't really need the messages inside the queues, and then don't declare your queues as durable, and just add a retry mechanism in your code and a redeclaration on the code side. So when a node goes down, the queues are going to be destroyed, and then your code redeclares the topology and go on with its own life. On the contrary, if you really need the messages and the queues to be durable and survive reboots and so on, you have to flag them as highly available. And you have two ways to do this. Classic HAQs, which tend to be replaced by another kind that I'm going to introduce later, which is basically just the normal way of doing queues in RabbitMQ, but adding promotable mirrors, which are synchronized. And the other queues, which come with the 3.8 release of RabbitMQ, are based on the Raft consensus, like many other tools like etcd or soon Zookeeper, I think, or maybe Kafka. Well, And sorry, just had a little issue with my headset. So quorum queues, which come with a 3.8 version. If you are doing HAQ, just be aware that, of course, HAQs come with downsides. They need more RAM. So if you have a lot of queues and a lot of messages, you will have to be aware that you will consume more resources. You will also have a lot more latency because mirror have to be replicated, and less throughput, of course, because if you increase latency, you reduce throughput. That's mathematical. And be aware that with classic queues, you have multiple modes, which all have their own implications. HA mode basically tells you how many mirrors you will have. And the more mirrors, the more latency and the less throughput. And HAsync mode, which can be a bit problematic if you have big queues and changing topology number of nodes often, because it may, in some cases, block your queue while the queue is being replicated. One last issue we had on deploying our clusters were that the person before me deployed the cluster with an even number of nodes in the cluster. And having worked in the field for some years, I have worked with many clusters, disk clusters, Linux clusters, storage clusters, and I tend to not be really confident when active clusters are working with an even number of nodes. And the main reason for that is that sometimes, even if it's not really happening very often, network partitions happen. What is called a network partition, or sometimes you can hear talking about split brain, is when the two half of your cluster are thinking that the other one is dead, and when in fact it's not, and it's only that there is a network connection that is severed. And what is really problematic with that is that software tends to write to both sides of the cluster, which is really hard to reconcile afterward. So even though with RabbitMQ, it's theoretically possible to build cluster with an even number of nodes, I don't recommend you to, because it's so easier to have an odd number of nodes to avoid the split brain and network partition issues. Now that we evacuated the issues with the platform and the architecture of our RabbitMQ, we also encountered a lot of issues with our own usage of RabbitMQ, or how we built our code around RabbitMQ. And the first one, and I'm going to really insist on this one, is security. Because when you begin to work with RabbitMQ, you read tutorials where you had users with a lot of rights when you don't restrict them, and it's too bad. It's a shame, because RabbitMQ comes with features to restrict access to queues and even to vhost. You can isolate your clusters in virtual subdivisions of your own cluster. Those ACLs can be assigned to users to configure read-write queues, and they can be applied on patterns of queues with regex. And what we realized after a few months of using RabbitMQ was that we had built a lot of microservices which were working and writing and consuming from multiple exchanges and queues, and we had a big cluster, and we weren't able afterward to tell easily which application was writing to which queue. And that was problematic because we had no easy way to restrict the rights without risking to cut production should we fail to add one queue in the whole rights. So when you start working with RabbitMQ, think well what you're going to how you're going to name your queues, because and also put ACLs really soon, because it will be really hard to add them later. What you can see on the right of the screen, and which is a bit blurry, but it was intentional, is a representation on a little part of our cluster. So we made a bit Python program to recreate from the API information the whole graph of all communication going inside and going out of our RabbitMQ cluster. And as you can see, there were a lot of connections and communication, and it's even a little part of what we were doing. So put ACLs from the beginning. That's really important. Another rookie mistake we did, like many people, was to don't use correctly connections and channels. I took this print screen from a well-known a well-known blog post, which is written by Lovisa Johnson, 13 common RabbitMQ mistakes, and the number one rule is the number one thing she says is to be aware that AMQP is really TCP loving, to say it like that. So when you open connections, you make a lot of requests, TCP packets, and if you open connections and channel just for one publish or one consume, it's going to make a really poor performance. So obviously, don't open a connection for each message you have to write or consume. And a little bit less obvious, but still important, in the same way, don't open a channel for each publish. And also, don't forget to close when you things, because we had an issues that came in production where microservices were opening thousands of channels. You can also put limits to restrict the number of channels that can be opened by a specific user or connection. It's really important because even though in our case there were no issue with this bug, if you have a lot of microservices that open too many channels, it's going to consume a lot of resources uselessly on your clusters. Another great feature of RabbitMQ and AMQP that we leverage is the Prefetch, which allows a consumer to get messages, more than one messages, even if acknowledgement hasn't been received on the broker side. And that's really useful for the applications that can manage that can manage to process messages really fast or faster than acknowledging, or even working in parallel when you don't need ordering of your messages. The downside of this is, of course, that the more messages you send in the wild, the more messages may suffer issues when something wrong happens. And one of the issues we had with Prefetch, one of the many issues we had with Prefetch, is that we sometimes wrongfully assumed that our application and the frameworks we used handled correctly the treatment of messages in parallel. We had an issue where the messages were taken in the consumer to be treated in parallel, but for some reason, one of the threads containing one of the messages crashed. And instead of being the only thread crashed and continuing to consume all the messages, the whole app, for some reason, was stuck because the messages were not really treated in parallel. And even though only one message was malformed, the whole prefetch messages were stuck. And we basically had to kill the app for the unhacked messages to come back in the queue and be treated by another app. The more microservices we added, the more we had to suffer from issues from badly configured application. One very important thing with RabbitMQ to have the best performance is to keep the queues short and to empty them quickly. And in some clusters, we had people that were leaving the messages for some time, and we were getting more and more queues that were never emptied. Sometimes with thousands, tens of thousands, hundreds of thousands of messages. And even though it didn't bring the cluster down, it was impairing the performances of the overall cluster. If possible, I recommend you to put TTLs on your queues to delete messages if, for example, your messages don't have any sense after 1 minute or 1 day, I don't know, depending on your software and your business logic. Keep queues length, add messages max size, add DL queues when those messages expire or are trashed. You can use DL queues to audit why they were trashed. And if you handle some kind of reject and requeuing in your code, be really careful not to loop, because we also had these kinds of issues when teams were requeuing messages that were not properly treated, but the same microservices took the same message and we looped forever. And it's really hard to break out that loop. And one last advice I'm going to give you is to observe. We have the chance to have a really nice management plugin UI, which is really cool, which gives a really good view, overall view of the clusters and the queues and what's in it. My advice is to put it not on only one node, because it's when you need it the most that you will have a node that is down or overloaded. And the RabbitMQ management plugin tends to be unresponsive when the node is under heavy load. So having it on more than one node is a good idea. And also, I also advise you to add the Grafana dashboards, because you will have a much more powerful view of your own business logic in a very central way. Use Prometheus to scrape your clusters and your queues into metrics. And one another really awesome feature of 3.8 was the addition of the official RabbitMQ Prometheus plugin which was really, really much more efficient than any other external exporters that we used in the past. So it's really easy to use. It's really easy to set up. You really should enable it everywhere, every time, and use the Grafana dashboards that come with it. And now I hope you learn some things and that you know that you may have some things to fix tomorrow. I'm going to just recap a bit what I really want you to remember. RabbitMQ clusters aren't what you think they are. What you really want are quorum queues or HAQs. RabbitMQ ain't Kafka. If you want to have a good performance, you don't want to store millions of messages for a long time. Use your connections and channels wisely. And bonus points. Secure from the start with ACLs on all your users. And observe, observe, observe. And that's all, folks.
Thank you, Denis, for the talk. It was pretty nice. Let me start with the first question. Zachary Attas, if you are here and you can, I think you should be able to unmute yourself, and please, if you can, state your question.
Yeah, I just thought the prefetch problem you described is pretty interesting. And was that, do you think, with a way that the application had coded their logic so that it depends on like the first in, first out kind of idea, and if one process crashed, then it took out a bunch of other ones? Or I don't know if I can get more detail about that.
Yeah, it's in fact it's a real weird issue, and we took a lot of time to try to understand, and we were not really sure that it was on our application side that was the issue, but more on the framework we used. Supposedly, the framework was supposed to treat the message in separate threads. So when you think that really you have multiple messages that are treated at once. But what we realized that it was not really. I don't really know, but it felt more the sequential and not really treated in parallel. And when one was stuck, the whole application was stuck. And we had really issues to fix this one. And in the end, after a lot of digging and a lot of auditing the code, we just removed the prefetch to ensure that we wouldn't get stuck. But it was really frustrating not to be able to find out why it was blocked.
Thank you for the answer. I hope that answered the question, Zachary. Matt, your question would be the next. So Matt Green, you should be able to unmute yourself.
Okay, thanks. Yes. Can you hear me?
Yes.
Yes.
Okay, cool. Sorry, I forgot to pick up my headset. I was just asking about how do you consider the best, or what do you consider the best way to deal with problem messages? So ones that the microservice can't currently deal with, either because it's malformed, there's some kind of miscommunication over the format of the message. Because we have a problem where we've got a whole stack of them. They move them into an error queue, and then they never quite get dealt with, which kind of breaks the golden rule of not treating it as a database.
Yeah. We also, of course, had this question. In some cases, the messages that were discarded were put in DL queues, and then we decided to audit them later, and we also built a program to requeue them when we decided that that it was a code error, that the message were correctly formed and it was an issue in the code, or we rewrote them and then we re-injected them. There was no one rule. It depended really on the context. Some teams put messages in DL queues and forgot them forever, which, as you said, is not really a good way to deal with it. Teams really work really hard to make sure that every type of messages malformed was fixed, and every error was caught, and when it was possible, fixed on the fly. There is no one rule for this.
Okay, thank you.
Thank you for that answer. We have just some feedback from Gerhard. I don't know, Gerhard, if you want to say it out loud as well.
Thank you for the talk, Denis. This was great. Thank you.
Thank you.
Thank you for the RabbitMQ Prometheus feedback. I'm really happy that it works so well. One of the biggest differences is that it doesn't traverse the cluster. So all the metrics are node local. One of the biggest reasons why management gets slow is because to get the data, it has to traverse the cluster. So if any node is overloaded, you won't get any data back. And guess what most integrations use? Datadog, New Relic, all of them. I mean, there's no specific names. They use the HTTP API, which suffers from the same problem because the management UI uses that. RabbitMQ Prometheus from the get-go was designed to not do that. It just only serves node local metrics. That makes a big difference.
Yes.
Streams change everything. Billions of messages is okay, and it's actually normal.
Okay.
So yeah,
I'm going
all
to
is changing.
I'm going to update my talk for next time, though.
Great talk. Thank you.
Thanks.
Yeah. Thank you, Gerhard. Next question would be from Cosmo Abdon, I think. I think you should be able to ask the question now.
Okay, so hello everyone. So let's say I know about the prefetch count, so I know how I can treat the message. But if I need H limit between my server and my consumer, or between consumers, how I can do that? And that's possible for me to have a key, so I can H limit based on that key. So I have user 1 and user 2, and each of them have different H limits.
Okay, so I'm going to be honest. I remember that we had this talk with the software engineers when I was at Lectra before my current job, and I don't remember what we found comes as a solution for this issue of having a rate limit. So maybe someone else can answer, but I'm sorry, I don't understand if we found a solution for this.
Okay, thank you. Next question would be from Terence Reed. I think. Let me try to. Yep. Please, Terence, if you are here.
Hi, afternoon or evening. So I was curious if there were any sort of obscure broker configurations that you've tweaked to improve your performance. Like I've played around with the credit flow and delegates to sort of improve synchronization and reducing connections in flow or channels in flow. Just if you have some experience with that or other odd configurations that most people sort of shy away from that you've had success with to improve performance.
We didn't. We tried a few. Some of those from Michael Clichin's RabbitMQ operations, but in the end, it depends so much on the workload, and in the end, the only parameters we tweaked was the memory watermark, which is really low. It was really low for us, and we could bump it a lot more. So that's not really obscure, but it's a default parameters that most people don't change, and I often bump it up a bit. Aside from that, no.
Thank you for the answer. Next question would be from Sergio Gianazza. So yep. I think Sergio, you should be able to unmute yourself.
Yes, sorry. Hello. Thanks for the talk. It was super interesting. Yeah, my question is that if you ever had a problem or experienced a problem because a different version of the management plugin from RabbitMQ and the RabbitMQ server version, I had this problem a couple of weeks, I think a month ago, that we have a different version, and basically the nodes couldn't connect between them. And yeah, given that this session is about 101 ways to break your RabbitMQ, I want to know if you ever experienced this.
Yeah, I have not experienced this issue itself. Although with management plugin, in very old versions, we had an issue when we had multiple versions, multiple management UI in the same cluster. So in the talk, I tell you that to put the management UI, the management plugin on all your nodes. But in fact, in very old version of RabbitMQs, I don't remember which one, we had an issue when we put more than one management plugin, it kind of broke. So no, I have not encountered your specific issue with the management plugin, but I did have an issue a few years ago.
Cool, thank you.
Can I add something very important?
Yes.
The management plugin is a tier 1 plugin. You should never use a different version than the Rabbit version. It's all bets are off if you do that. And yeah, I mean, Rabbit itself, it just ships with the plugin. So you literally have to take the plugin from another version of Rabbit and put it in a different version of Rabbit. That's very hard to do.
Thank you. I think we still have time for this question as well. So Dominic, if you are here, please.
Yeah, sorry for not posting the question there. I messed up the copy pasting. But my question is basically what we experienced in the past is when a Rabbit node shuts down, the connection to the consumer application basically breaks, but it continues to run whatever is triggered by the Rabbit thread, by the consumer thread. At the same time, we also put the message back on the queue and then receive it once again. Do you know how, or did you ever experience something like that, and how did you handle like non-idempotent actions you trigger within? So an easy way would obviously be just having some kind of future locking mechanism. But in case of a service which has no app-DB, it's rather problematic to do something like that. Do you have an idea there?
When I was at Lectra, we didn't have many services that suffered issues when messages were not received exactly once. On the few services that were impacted with such issues, I know the developers put in place a mechanism and to make sure the IDs of the messages were only received once. So, but it was not really an issue for us. The microservices were mostly not really impacted by receiving a request twice. I know it's not really helpful, but
Thanks a lot.